Hello everyone. My name is Mohammed Ibrahim. I am final year BE in Electronics and Communication Department from Enapoya Institute of Technology. I got selected for Emertxe Embedded System Internship from Emertxe. Uh, that was a wonderful internship I got till now. Um, they explained very well. I understand the news concept which I didn't know about that from embedded systems. Uh, as I said, I got to learn new things. These are the things learned in 4 weeks of internship program from MIT Technologies. In first week, they taught us how embedded system programming can be implemented in embedded systems, how C programming can be used in embedded systems. They introduced C programming used in various applications in embedded systems. Uh, then they introduced the C program from scratch. Uh, First, they taught us about data representation. How can we represent the data? Uh, then then is basic data types. There are int, float, char, unsigned char, signed char, static data type, external data type. How these data types can be used in our C programming. Uh, then they taught us about conditional constructors. Uh, conditional constructors as while loop, do while loop, and for loop. How can be used in programming? With the example, they taught us how can be used in the programming. What are the challenges we can face? Then operators. Uh, Talking about operators, there are different types of operators: bitwise operator, uh, a logical operator, arithmetic operator. There are more number of operators. They taught us how bitwise operator can be used, such as bitwise and, bitwise or, then logical operators, then conditional operators. How can we use a conditional operator in instead of if, else if and more number of nested ifs, we can use conditional operator. Then array, uh, how elements can be stored in array, two-dimensional array, one-dimensional array. Then pointers. They taught us about the pointers, how pointers can be used in C programming, how pointers used in array, how can we fetch the data from array using pointers easily, how can we use it in other functions. Then they taught us about functions, how built-in functions, what are the types of functions, built-in function and user-defined function, what are the different built-in functions, and second is how user-defined function can be declared, defined, and how can we use it, how can we implement our own function. Then they taught us about storage classes, what are the different types of storage classes. Uh, then about preprocessors, what are the preprocessor used in C programming, such as hash include, std.h, or hash define preprocessors. In week two, mm, there is project scheduling and intro to embedded systems. Uh, they introduced what is embedded system, how what are the various application the embedded system has, uh, what are the broad range of embedded system, and for the project schedule, and for the project we need the development tools to build the project. To for that, they taught us how to install the development tools such as MPLab, XID, and PiximLab. Uh, then they introduced embedded system and introduction to microcontrollers. What are the different types of microcontrollers? Uh, which microcontroller we are using in this project? In this project, we are using PIC16F877A microcontroller. They introduced about that microcontroller. What are the internal circuit of that microcontroller? Then coming to our project, which is car black box explanation. They did the explanation about what is the project we are going to do, what are the specification this project include, how can we achieve the project. Then then we started the embedded system, embedded programming first code using LED, which is the basic program. Um then we started use LED. Then we started some altering the program and executing the program. Then we uh, view the result using PiximLab. Then they taught us about PiximLab overview. What is the specification we can use in PiximLab? Then what is MPLab XID? What is MPLab XID? Which are the compilers used can be used in MPLab XID? Then they taught us about LED program demo. That's all. That's it about week two. Then coming to week three, we started with the embedded programming for digital keypad, which is a keypad used for inputting the input, and they taught us about interrupt, different types of interrupts. Then timer. What are the timers included in our microcontroller? There are three timers: timer 0, timer 1, and timer 2. Um, then what is the prescaler and intro to ADC? That is analog to digital converter. What are the terminologies in ADC? And they taught us about single channel detection program, uh, which can be used in our project. Then introduction to CLCD, which is a character LCD, liquid crystal display. Uh, what are the specification about CLCD? Then what are the different types of LEDs, LCDs are available? Then communication modes, different types of communication modes uh, used. Then clock, CLCD 8-bit driver code. How can we print the CLCD, print the uh, statements in CLCD display? Then they taught us about RTC, which is the real-time clock, which is useful for fetching the real time. Uh, then we are using, they taught us about I2C in week 4 for when we using project integration and testing, project implementation using MPLAG XID and PiximLab. In this week, they taught us about RTC and I2C protocol, which is used for communication between uh, RTC and microcontroller. In week four, we integrated the project using all the peripherals which we need, such as the digital keypad, interrupt, timer, ADC, potentiometer, and CLCD, I2C, RTC. All the peripherals we integrated and we tested using our code. These are the contents. What is car black box? Then is project requirements and what is embedded system? What is microcontroller and microprocessor? What is the difference between them? Then is introduction to peripherals which we use in our project, then project implementation and demo. Coming to the question, what is black box? We are implementing the project which is car black box. The concept of car black box, which we can see in flight or airplanes, is similar to that. You can see in airplanes there is a black box which is used to store the event that occurs uh, after the plane started and um, which is used to store the information of different events such as conditions as the time, speed, gear conditions, what are the top speed, what are the amplitude, and other things. In this, we are implementing this in car, so we are only using time, what is the speed, and what is the gear condition. Car black box, I can say black box can be used to constructing safer vehicles, improving the crash victims, and helping the insurance company to with their vehicle crash investigation and enhancing the road status in order to decrease the death rate. To achieve this project, we are using PIC 16 F887 controller and 16 is to LCD display and digital keypad, and we are using RTC for storing the real time and I2C for communication mode for onboard communication. Here we are using software simulation. For this, we are using MPLAB XID for programming, which included with XE8 compiler, and we are using Pixim for simulation of the project. These are the project requirements. Here we are using two software tools, which is MPLAB XID, which comes with XE8 compiler user for compiling, and PiximLab. We are using PicGenius board with the PIC16F887 controller. Coming to MPLAB XID and PiximLab, these are the two software tools we are using. MPLAB XID is by microchip and PiximLab. PiximLab is a real-time simulator of development modes with integrated MPLAB XID debugger. It supports some Pixim controllers and some sim-aware microcontrollers. The MPLAB XID integrated development environment, it can be extendable, highly configurable software program that offers powerful design tools. Uh, Comes with the debugging and programming of microchips, 8-bit, 16-bit, and 13-bit uh, thick microcontrollers. Then comes with the question: what is embedded system? Uh, there is a various definition for embedded system. Uh, that is a clear-cut definition can be any combination of hardware and software which is intended to do a specific task can be called as embedded system. Embedded system means it's a combination of hardware and software which use it to uh, do the specific task, only use it to do the specific task. Embedded systems can be categorized as standalone, real-time, and networked and mobile. Uh, There is a real-time aspects can be again classified as hard real-time systems, firm real-time systems, soft real-time system. In hard real-time system, the system should meet its deadline, which is a life critical application. It can be example for this is flight control system, missile guidance system. If there is a second delay in that can be lead to life critical application. And second is for real-time system. Uh, in this real-time system, few missed deadline will not lead complete failure, such as video conference, satellite track. Uh, then third is soft real-time system that can have tolerance in meeting its deadline, such as web browsing, railway ticket reservation, and other things. Uh, what is examples of embedded system which we are using in our daily basis, which is micro oven, TV, washing machine, rover, missile, and routers. Then what is microprocessor and microcontroller? Uh, Microprocessor and microcontrollers are integrated circuits of small chips that used to perform computing and control functions. Microprocessor comes with the CPU and our brain of microcontrollers, while the microcontroller is a computer that comes with shapes and size along with the other differences like device type, task performed, architecture, efficiency, computation, storage, cost, and speed. Example of microprocessor can be our general computer, while the microcontroller can be embedded system like a TV, washing machine, mobile phone, and other things. What is the difference between microprocessor and microcontroller? Uh, Microprocessor are more flexible, which we can change the RAM, we can change the ports, or we can change the ROM and other things. Um, it has more design complexity, hence the peripherals are outside the chip. So the design complexity is much difficult. Um, uh, and then is microcontroller. In this, all the components are in single chip, so it's less flexible. Uh, but the drawback is we can't change the RAM or we can't change the ROM. It is fixed, and it has less design complexity. This is a microcontroller used in our project, which is PIC16877A. These are the peripherals included with this microcontroller, which comes with GPIO pins, which is general purpose input-output pin, um, and this I2C, which comes with I2C protocol with RTC and double EEPROM for storaging, and LM35 temperature sensor, and ADC, analog to digital converter, CLCD, matrix keypad, SSDs, digital keypad, buzzer, LEDs, RS232. Uh, we are using this microcontroller for our project as per suitability and convenience. Then last is what are the peripherals which we are using in our project. Uh, in PICSIMLA we used the PICGenius board with the PIC16F877A microcontroller. Here are the peripherals which included with this board, uh, which we learned and integrated all the peripherals to build our project. Uh, First is 16 is to CLCD display to display the records and login process, and RTC, real-time clocks for real-time. RTC protocol used for onboard communication between microcontroller and RTC. Then we are using tactile switch for scrolling. Then we are using ADC for analog to digital converting from potentiometer. Then we are using internal EEPROM for data storage to store the events, and we are using timer source for delaying the delaying some information. What is 16 is to CLCD display? CLCD 16 is to CLCD display is commonly used. uh, display ASCII characters. Some customization symbol is possible. These are the two communication mode can be used in CLCD display, which is 8-bit mode and 4-bit mode. These are the switches. These are the pins which is included with CLCD display. Uh, these are the port D pins, and one is ground RE2 for enabling, um, RE1 is reset pin and enable pin, and read write pin. Then peripherals we are using is RTC, which is real-time clock. Real-time clock provided by microcontroller for integrated circuits. It has separate battery backup, which use low power consumption. RTC has a feature of onboard communication with microcontroller using I2C protocol. Then we are using analog to digital converter to convert the signal from potentiometer to digital. Here we are mainly using this peripheral for potentiometer for speed control. It is most commonly used in all type of microcontrollers. There are types in ADC, which is flash ADC, pipeline ADC, SAR ADC, dual scope ADC, Sigma Delta ADC. We are using SAR ADC for our project. Then is tactile switch, which is digital keypad. Digital keypad is mainly used for select the mode of operation and to enter the required gear events in our project. And also switch between the events, switch between the locks, menus, and click the menu, and to reset the password. And also we are using the digital keypad. It has a combination of switch comes under digital keypad. Use a bouncing effect when is pressed. As you can see in our digital keypad, in a tactile switch there is a metal plate and also there is a terminal. When this switch is pressed, the metal plate produces a bouncing effect. Uh, then the switch has two mode of operation, which is edge triggering and level triggering. In edge triggering, what happens in edge triggering, only when the clock is changing, the output is changing. Uh, in level triggering, throughout the clock, the output is also changing depending on the input. Uh, Here we are using two types of resistor circuit. One is pull down resistor circuit and pull up resistor circuit. In pull down resistor circuit, when the switch is not pressed, uh, when the switch is not pressed, the reading to the controller will read as 0. When the switch is pressed, the controller will read as 1, which is there is a VDD source in there. In pull-up resistor circuit, when the switch is not pressed, the controller will read as 1. When the switch is pressed, the voltage will go down to ground, so the controller will read as 0. Then we are using timers for delay. Timer is an important application in embedded system. It has to maintain the timing of operation in sync with the system clock or external clock. The timer has so many applications as the measuring the timing, generating delays, and timer is a software designed to plot the time intervals between events. Uh, in timer, there's the resolution is called register width in timer. The tick is referred as the change of one number from next number. It may be up count or down count. In our microcontroller, basically has three timer modules, which is timer 0, which comes with 8-bit resolution, and timer 1 with 16-bit resolution, and timer 2 with the 2 8-bit register, timer 2 and TMR2 and PR2. Then is how we can implement this project in our simulation. Here comes with the project demo and explanation. In this project, we are using two tools, which is MPLab XID and PiximLab. Uh, Let us introduce each tool. For implementation of project, we have to create new project, and then we have to select the board and compiler, and what is the project name. After that, we get this project window. In this, we have to include all the peripherals .h and .c files which we learned in our internship. Um, After that, we are using ADC, CLCD, digital keypad, I2C, timer, and RTC .c file, all the .h and .c files. Um then we have to define one .c file for our project, which is car black box. Defined one .c file. In this project, this .c file includes all the necessary programs for our project, which we implementing. Uh, it is then we comes with the .h file. Let us introduce the project explanation. In this, we are using we can uh, use other boards. We are using Big Genius board. It comes with the PIC16F877A microcontroller. This Big Genius board includes this controller and EEPROM, RTC, uh, DAP switches, buzzer, cooler, relay, uh, and which comes with the tactile switches, tactics keypad, LEDs, potentiometer, and also with LCD display, CLCD display, 7-segment display. We are integrating all these peripherals to build our project. For our project, we are using LCD and tactile switches, potentiometer, microcontroller, EEPROM, and RTC. The basic idea of our project is to record the events when from the starting of the car. When the car starts, this is the time. This is the dashboard of our project. It includes time, event, and speed. Here we are recording the time, event, and speed. We can switch between to switch gear up, we are using this switch. Gear down, we are using this switch. And for collision event, we are using this switch. Uh, let us let me show you. As you can see, as I pressed this switch, the event changed with neutral gear, and then we can move to reverse gear, gear 1, gear 2, gear 3, gear 4. We can up the switch for the event, and also we are measuring the speed using a potentiometer. We can also vary the speed using potentiometer. And for collision event, we are using this switch. uh, and then after all the events, we have to, after if the collision occurs, if the car got to accident, after investigation, we have to see the black box, we have to open the black box. For that, we have to store the all the events in one place. For that we are using EEPROM. Uh, uh, Using the built-in functions of EEPROM, we can store the all the events. Uh, to view the events, we have to first, this is the password protected. We have to enter the password. Here we set the password as this is 2 and this is 4. For this switch, this is 2 and 4. I set the password as 2424. To enter, let us enter the password 2424. The password, we are getting two options, three options, which is view log, clear log, and to change the password, we are getting change password option. uh, first we can view the log. To view the log, we select the switch. We are using this switch. Here you can see the logs. All the recorded logs can be viewed from this first log, second log, and the second event we are in reverse gear. In the third, we are in first gear, and in fourth event we are in uh, second gear. These are all the recorded events. Maximum we can store 10 events in this project. Uh, this project. Uh, Let me come out of this. We enter the password. If you want to clear the log, we have to select this option, this clear log. By selecting clear log, as you can see, logs cleared successfully. All the logs previously recorded logs are deleted from the uh, EEPROM. Now, by checking a view log, we find no logs found. In this, we can say all the logs are deleted uh, from the EEPROM. Loading. Explore the third option. First, we have to enter the password, and scroll down. As you can see, we have to enter the new password. As I enter the new password, it gives me the another option to re-enter the new password. If the password matches, it says password changed successfully. If What if the password doesn't match? Uh, if the password doesn't match, it gives the warning that the password changed is failed. Then we have to come out of. Then it comes out of that menu. Then we have to try by entering the correct password. This is the idea of our project. We can implement this project using this MPLAB XID uh, and XMLab. As you can see in our program, we are using the cloud car black box dot definition project and main project. In first, we are using the we are creating the dashboard using create dashboard. We have to create the dashboard. Then we are using the switches to select the events such as gear 1, gear 2, gear 3, and all the gears, reverse gear and other gears. Here are the gears: gear, neutral gear, gear, reverse gear, gear 1, gear 2, gear 3, and gear 4. This is for clearing the display and to clear the log and change the password. First, we have to initialize all the configurations using init this function, which is all the configurations: CLCD, I2C, switch, RTC, ADC, diesel keypad, and time. Have to win. Also, we are using interrupt. In this we are using password like 2424. To write the password in EEPROM, we are using EEPROM write, and also we are using key for diesel keypad, storing the key which switch is pressed, and also we are using reset flag. Also using menu position, what is the position of the menu, and also we are using event, what is the event, and speed. We are initializing the event as on, this default, and on speed is 0, and this first we are creating a dashboard flag. We are using the switch statement for switching between the different flags, such as dashboard flag, login menu flag, and other. Here for delay, we are using timer 2. Uh, as you can see, for changing the password, we have to we use switch for change the password. First, if the task is success, we of the cursor, then we go to login menu and research the login menu. This is the code which I have written for our project. First, we are reading the clock, which is hour, min, second. From RTC, we are reading the clock time, and we are displaying the time. Uh, and also for displaying the dashboard, we are using time, event, speed. For putting the each character at a time, we are using CLCD puts ch function. This is the built-in function. And also for the log event, we are using log event function. If the position is equal to 10, we are resetting the position as 0, and for the address, we are using position into 10 plus 5. These are the different approach we are using to display the log event. And then we are using a log car event, which is to display the speed. uh, then we are using clear screen to clear the screen. We are using login uh, for uh, for storing the password. How password can be stored in using the switches. And then we are using different types of approach. If the attempt, we are giving 3 attempts to enter the password. If the attempt is 0, after entering 3 times, if the attempt is 0, we are blocking the user for 60 seconds. As you can see in our project, if I enter, the wrong password, it is giving as wrong password to attempt remain. Uh, after certain time, if I enter then also the wrong password, it is giving as one attempt is remaining. Then after also, if I press the third time, if I press the wrong password, it is saying that you are blocked for 60 seconds. It is counting as uh, seconds. After reaching the 0 second, it comes out of this block and print the login menu. Also, after blocking 60 seconds, it asks to enter the password. These are the functions. For our login menu, we are using key and reset flag. If the reset flag is equal to login menu, we are resetting the position as 0. We are increasing the position, we are decreasing the position. And also to view the log, we are implemented the view log function. If the no logs, if the, after clearing, if there is a no log, we are printing as the no log if event count equal to -1. To view the log, we are using the switch 5 and switch 6 to select up and down. This CLCD puts CS to view the log in using a CLCD display. And also for clearing the log, we are using this function. If the event count is -1, means the log is cleared successfully. For changing the password, we are using this function. For change the password, uh, enter new password, re-enter new password, and that's all. Yeah. If the password is same as previous, then password changes successfully. If not, password is not changed successfully. These are definitions which we functions we usually in .c file. Then we are using main.c for main op. If uh, to count the speed, we are using this um, formula, which is read ADC divided by 10. Then these are the different approach to read the events. Then first we enter the asking to enter the password. If the password is matched as a stored password in Ethereum, then we are giving access to view log. This is a switch control flag for switching between different screens in CLCD display. As you can see, after 60 seconds, it comes to the event log. Uh, that's all about our project. This project can be used in our block blocks. It can be we can use it